Hello, how are you, students? One more week in our online learning. I just want to tell you how much we miss you once again and how we can continue to learn even through these means. All right. We're here to help you in any way that you need help. Please contact us if you don't understand something. We can do video conferences. We're still here to help you guys. All right. So we're going to start today with 8.5b. That says we will interpret the arrangement of the periodic table, including groups and periods, to explain how properties are used to classify elements. So if you look here, thinking back on some of these vocabulary words, we have groups, periods, right? And how they're gonna, how the properties are gonna use, help us to classify elements, okay? So start thinking back, like what were groups, what were periods, and what direction did they go in the periodic table, and what do they tell us about a certain element, okay? So first of all, I'm showing you here a picture of an atom, and the question says, what are my characteristics? So just from the picture, what can we tell? I'm gonna pause a little bit to give you guys some time. You can pause the video, and I want to give you guys some time to look at that picture and kind of make a list of characteristics that you can tell from the picture. Some things that you may notice. All right, first of all, protons are located where? Right here in the nucleus, in the center of the atom. Okay, now for this case, it doesn't really matter because, well, they're equal, right? 1, 2, 3, 4, 5, 6. There's 6 protons, right? How many, what else is located in the middle? Neutrons. And it's 1, 2, 3, 4, 5, 6 as well. And these are your electrons, right? And there's 1, 2, 3, 4, 5, 6 as well. Okay, so those are some characteristics that we can tell right off the bat. Okay, so first of all, protons are in the center, like I said. Neutrons are in the center, and electrons are around the nucleus. You need to know we had that atom in the back of the periodic table, that anchor chart, telling you, all year long from the beginning of the year, protons and neutrons are in the center, electrons are in the electron cloud. They have their own special place. So because of that, we can tell that this element is carbon. And if you remember, that atomic number gave us the number of protons and electrons. So your protons and electrons are always the same. In this case, they're 6. Because why? The atom is always neutral or balanced. So because of that, 6 protons and 6 electrons, we know the atomic number, which is 6 for carbon. The number of protons equals the number of electrons equals the number of protons. Once again, protons and electrons are always equal. Why? Because protons are positive and electrons are negative. And I need to have that balance. The same number of pluses and the same number of negatives. The mass is 12. Remember, where does the mass of an atom come from? From the center of an atom. So that nucleus, the nucleus has all the mass, and that's where we get 12 from, because the nucleus is made up of 6 protons and 6 neutrons. So 6 protons plus 6 neutrons gives you that mass of 12. And it has an overall neutral charge. The atom is neutral. The atomic number is 6, like we said, because of the protons and electrons being 6. And it has 4 valence electrons. That's going to be very important for us when we're going to be discussing reactivity. So once again, these outer electrons, this right here, the outside ones on the outside shell, all of those are called your valence electrons. They have a special name, okay? Valence electrons. All right. And lastly, you have 2 energy levels. Because why? Only 2 fit in the first shell. And then once that shell is full, you go on to the next shell, and then you have 4, okay? So 2 energy levels. And that's important for groups and periods, remember? Valence electrons and energy levels. is important for groups and periods. All right, let's just review a couple of things. First, matter. Everything around us is made of matter. It takes up space and has volume. It is matter. So matter, tree, water, air, all of these things take up space, all right? And they have a volume. Not matter, energy, emotions, ideas. Matter is composed of incredibly small atoms. Atoms are the basic building blocks of all matter. So here, once again, it breaks down the structure of atoms. If you notice, this one doesn't have the energy levels because it's just demonstrating, the electron cloud. We have the nucleus, which is made up of protons and neutrons. And then the electrons are kind of just flying by in the electron cloud, and those are negatively charged. Protons are positively charged, and neutrons are neutral, nothing, no charge. That breaks it down for you in the next slide. If you need to take notes, I would pause this. Protons are positive. They have a mass of 1 AMU because they are located in the nucleus, and the nucleus has all of the mass. Your number of protons equal the number of electrons. Next, you have your neutrons. No charge. They have a mass of 1 AMU because they're also located in the nucleus. All my mass is located in the nucleus. And electrons have negative charge with a mass of 0 AMU. They don't really necessarily weigh AMU. We say almost 0. And they're located in the electron cloud. And I always told you guys, think of a cloud. It doesn't have mass, okay? Atomic number is the number of protons in an atom. So the number of protons, or the atomic number, determines the identity of an atom. The atomic mass is the number of protons plus neutrons in the nucleus. So here we have protons is equal to the number of electrons. The neutrons is your atomic mass minus your protons, or what I taught you, atomic mass minus atomic number. That also works. And electrons will equal the protons. So it's the same two, but reverse. Okay. Valence electrons. So your valence electrons are just the electrons on the outermost shell, our energy level. All right, so hydrogen has 1 valence electron, as you can see there, meaning it only has 1 electron on the last shell. Carbon, you're only going to look at your last shell, this one. And carbon has 2, 3, and 4. Nitrogen has 1, 2, 3, 4, and 5. And oxygen has 6, okay? And once again, your valence electrons are important for discussing reactivity, okay? How well do they kind of bond with other? Valence electrons determine the chemical properties of atoms, including the reactivity of the atom. Chemical properties are atoms with the same number of valence electrons will have similar chemical properties. So that's why we have those special groups in the periodic table, like your alkali metals. Alkali metals, all of those metals have pretty much similar chemical properties. Alkali earth metals are all kind of similar in their chemical properties. Halogens and your noble gases. Reactivity. The reactivity of an atom is its capacity to undergo a chemical reaction with another atom, how it reacts when you combine it with another atom. The capacity to react is dependent on its valence electrons. So groups run vertically and are made of atoms having the same number of valence electrons. So here, once again, you have your special groups, your alkali metals, alkali earth metals. You have your halogens in group 17 and your noble gases in group 18. And they have the same types of properties, okay? Why? Because they have the same number of valence electrons. The atoms that react most easily with other atoms have either the lowest number of valence electrons or the highest. So going back to this right here, remember that my highest reactivity. My highest reactive groups are group 1, because it's very easy for them to get rid of that 1 valence electron, and group 1 and group 17. Because group 17 has 7 valence electrons. And it's very easy for them to gain 1. As you start getting closer to the middle, the reactivity kind of goes down, remember? And there's one group here that is not reactive because they have a full outer shell, and it's this one right here. Group 18 is not reactive because they have a full outer shell. Sorry, guys, I am trying to write with my mouse pad. So highest reactive is group 1 and 17. Then it goes down a little bit more. So group 2 is still highly reactive, but not as much as group 1. And group 6 is still highly reactive, but not as much as group 17. Okay. Group 18, not reactive at all. Okay. Atoms with the lowest number of valence electrons are highly reactive because they seek stability by releasing or letting go of that 1 valence electron. Either 1 or 2, it's very easy for them to release their valence electron. Atoms with the highest number of valence electrons are highly reactive because they seek stability by gaining electrons to fill their outermost shell. So those elements with 6 or 7, it's very easy for them to gain 1 or 2 electrons to gain stability. So today's assignment, or the assignment that you might do. This one right here is asking you, you have several elements, and it's asking you questions such as, which 2 elements have 1 valence electron? So what you're going to do is you're going to have to label your periodic table, okay? So on here you have 1 VE, 2 VE, meaning valence electron. Remember that groups 3 to 12, the valence electron rule does not apply to them, okay? Right here, 3 VE, 4 VE, all the way to 8 VE, okay? Sorry, guys. So once again, which elements have 1 valence electron? Which element is the most reactive in this table? And please don't just give me the letters, give me the name of the element. Most reactive, I went over which groups were the most reactive. Which element is chemically stable, meaning it's stable. It has a full outer shell, okay? So once again, you have a total of about 16 questions. If you have any help, please make sure that you contact us, guys. And with that, I'm gonna go ahead and kind of stop the video. If you have any questions, feel free to ask. Have a great day.